Redis makes a few design choices that, on their own, sound like bad ideas. It keeps all your data in memory, where it vanishes if the power blinks. It runs your commands on a single thread, while the rest of the world chases more cores. And it ships with a strange menu of data types most developers rarely touch. Any one of these sounds like a weakness. Put them together, though, and every weakness turns out to be the reason it works. Every choice is designed to remove waiting. To make this concrete, we'll build one small product in our heads as we go. A social app with users, feeds, and a live leaderboard, and watch each Redis choice pay off inside it. Here's the goal Redis is chasing. Read and write data almost instantly. One big reason normal databases feel slow is that they keep data on disk, and getting to disk is a long trip. Redis just doesn't. Everything lives in memory. Looking something up in RAM is like recalling a fact from your own head. Going to disk is like walking to a library and hunting for the right book on a shelf. Both work. One is in a different league for speed. That's the first weakness turned strength. Volatile memory in exchange for near-instant reads. But it creates two problems for later. Memory is limited and more expensive than disk. And memory is volatile. Pull the plug and it's gone. Keep both in the back of your mind. Redis solves them later. Now, if lots of clients want to talk to the store at once, the usual instinct is to throw threads at the problem. Handle everything in parallel. But the moment two threads touch the same piece of data, you need locks to stop them corrupting it. And locks are slow, fiddly, and a classic source of bugs. So Redis makes an unusual call. A single thread. Just one. It handles every client through something called an event loop, which lets one thread juggle thousands of connections at once. And it works because the data is already in memory. Most commands finish in microseconds, so doing them one at a time isn't a traffic jam. It's more like one extremely fast cashier who serves each customer fully before moving on. No coordinating with coworkers, no locking the register. Running one command at a time also gives you something for free. Every command is atomic. It fully happens with nothing sneaking in halfway. Back to our social app. Take the likes counter on a post. Normally, adding one safely is a hassle. Read the number, add one, write it back. If two fans hit like at exactly the same moment, they overwrite each other and you lose a like. Classic race condition. Because the cashier only handles one customer at a time, you just say increment. Every like gets counted. Counters, rate limiters, distributed locks, all easy. One catch, that safety is per command. If you need several to run together as one unit, Redis gives you ways to group them. But doesn't one thread mean it only uses one CPU core? Mostly yes. To use a big multi-core server, you run several Redis instances and split the data between them. Modern Redis uses extra threads for networking, but core command execution stays sequential. One command at a time. There is a real trap here worth naming. Single-threaded stays fast only while every command stays fast. One expensive query, a giant scan, a massive value, blocks every other client behind it. Keep your commands small. So far, Redis is holding simple values by key. That's already a decent cache. But here's the leap that makes it much more. Redis owns the server, and it's all in memory. So why limit it to plain text? Instead, Redis gives you real data structures and works on them in place, right on the server, instead of dragging data back and forth to your app. And here's the mental shift the rest of this section is really about. Don't reach for commands first. Ask what shape your data actually is. Match the shape, and hard problems just quietly fall apart. Back to our social app. You already know strings, plain values, and numbers like the likes counter from a minute ago. Perfect for user sessions. But say you store a user profile as one big JSON blob. Just to change their email, you pull the whole object into your app, parse it, edit one field, and write it all back. A hash keeps each field separate. Now you change just the email in place with one command. Nothing fetched, nothing reserialized. Now your app needs a background job queue. Thumbnail generation, notifications, whatever. The usual hack is a database table you keep polling. The moment you add a second worker, they start fighting over the same job. A list is just an ordered line. Producers push jobs on one end, workers pop them off the other. And because a pop is atomic, two workers can't claim the same job. Though real production queues still add acknowledgements or retry logic in case a worker crashes mid-task. Next, you want to know who's already viewed a post, or check whether someone is already following another user. With a plain list, you're scanning for duplicates by hand. With a database, you're paying for slow duplicate checks. A set only ever holds unique items. Duplicates simply can't get in. And is this in here is instant. Want mutual friends or shared tags? Intersect two sets and Redis hands you what they have in common in a single step. Now the live leaderboard, the trending posts section of your app. To show one post its rank, a normal database has to sort the whole table by score on every request, or keep a separate rank column that goes stale the instant anyone likes anything. A sorted set gives every member a score and keeps everything in order as you write. Top 10, or what's this post's rank, is instant, never stale. And here's the trick. Change what the score means and the same structure does a different job. Make it points and you've got a leaderboard. Make it a timestamp and it's a rate limiter or a recent items feed. Make it a priority and it's a priority queue. One structure, a dozen problems. Then a few specialists for when you need them. In event logs, several services can read and replay. That's a stream. Tracking whether each of 10 million users did something today without 10 million rows, flip one bit each. That's a bitmap. Counting unique visitors in the millions when approximate is fine, hyperloglog does it in a few kilobytes. What's near me? The geospatial commands. Every one of those was a real headache with the wrong data structure, and one simple command with the right one. Quick but important detour. How do you actually talk to this thing? Redis uses a deliberately simple, human-readable protocol. Plain enough to read with your own eyes, and cheap for a computer to parse. That keeps the server side fast. So where does the time actually go? Usually the network trip. Sending a command across the network and waiting for the reply often costs far more than running the command itself. Which explains a common mistake, firing hundreds of tiny commands in a loop, each waiting for the last. That's making the cashier stand there while you pick out your next item one at a time. The fix is called pipelining. Send the whole batch of commands together, then read all the replies at once. Redis is fast now, but fast data that disappears every restart isn't very useful. Time to pay off the two problems we parked at the start. First, volatility. Redis has two ways to save to disk. Snapshots take a full picture every so often. Think of a save point in a game. Compact, quick to reload, but if you crash between save points, you lose whatever changed in between. The write log records every change as it happens, like a journal. Replay the journal, and you rebuild your data right up to the last recorded change. More durable, bigger files, a little slower. You can run both together. The point is this: durability in Redis is a dial you set, not a fixed fact. The popular belief that Redis always loses your data on restart simply isn't true. How much it can lose is up to you. Now the second problem. Memory is finite. Redis has two tools. The first is expiry. Tell any key to delete itself after some seconds. Ideal for caches and sessions. One subtle thing when you're debugging memory. Expired keys don't always vanish at the exact millisecond. Redis removes them lazily when they're next touched and during background sweeps, so an expired key can linger briefly. That's normal, not a leak. The second tool is an eviction policy. When memory hits its limit, Redis has to decide what to drop. Least recently used keys, least frequently used ones, only keys that already have an expiry, or nothing at all, refusing new writes instead. For a pure cache, dropping least recently used is a sensible default. For a store where every key matters, turn eviction off and get alerted instead. Step back. Redis is fast not because of one trick, but because every part of its design removes waiting. RAM removes the trip to disk. Sequential execution removes locks. Server-side data structures remove trips back to your app. Pipelining removes network round trips. Every weakness we started with, volatile memory, one thread, a weird menu of types, turned out to be the reason it works. So when should you actually reach for it? Caching, sessions, rate limiting, job queues, leaderboards, real-time features, messaging. Anywhere speed matters most. But it has limits. Everything lives in RAM, so huge datasets get expensive fast. If your data is deeply relational, lots of joins, complex queries, strict integrity rules, a traditional database is still the better fit. And while Redis can be a durable primary store, most teams run it alongside their main database. Redis for speed, the database as the source of truth. If that was useful, please like, share, and subscribe. Thanks for watching, and see you in the next one.